Hello, welcome to this video on raycasting. So in this video we're going to be looking at physics.raycast, which is a way to just shoot a ray forward, just in code, just kind of an invisible ray, and detect what we hit, and that can be useful for different things. In this case we're going to use a raycast to check if the player's on the ground. And then we'll also talk about what method overloads are, and we'll look at layer masks, and those can be helpful with raycasting. So first of all, I'll let you know I chose a jump force of 5. I thought that was pretty good for my game, but you can choose whatever jump force you think is appropriate for your game. And let's see why we need to talk about raycasting here. So let's play the game. Okay, great. It's exciting. I'm following the rules by just pressing the jump key once in a while. And then I decide to press the jump key over and over again, and you can see my player really gets taken up into space there. So even before the game starts, my player is really able to just go right up into space because I just pressed the space bar so many times. And so we want the player to only be able to jump when they're on the ground. So what we're going to do, if I zoom into my player here, is in code we're going to make sure that the player is always shooting a raycast straight down. And that's going to go straight from the rigid body. So it's going to shoot down from the rigid body. And if we are hitting the ground, then I want to say, yes, we're on the ground, you can jump. But if the ray shoots down, maybe just to her feet here, and we're not hitting anything, then we'll say, well, you're not on the ground, you can't jump. So your space bar is not going to do anything. So let's see how that works. Okay, so let's go to our code here, and let's see where we want to check this raycast. So if we go to the update function, we see we have get key down, that's pressing space. Okay, now before you actually add a force here, we should check, is the player on the ground? Okay. And so to check if the player is on the ground, we're going to do a raycast. And to do a raycast, you just write capital P physics dot raycast. Okay, open up a parenthesis. Now here, by accident, I pressed the insert key on the keyboard, so I have this flashing gray rectangle. Now if that's getting in your way and that's annoying you, just press the insert key again, and it'll stop. So the insert key, if that's selected, if you put your mouse somewhere and you start typing, it'll just type over things, right? But if you press insert again, you're not in insert mode anymore. Notice down here it says OVR in Visual Studio. If I press insert again, that OVR turns off, right? So that's the mode you're entering into there. So anyways, we got out of that overwrite mode. So now physics.raycast, and open up these parentheses, and notice there's actually 16 different ways to use this function. So you could give it a ray. A ray is a specific data type that we could make, and we could give it a ray. Or we could give it a ray and a max distance to check, right? Or a ray and this struct called raycast hit info, or an origin and a direction. So there's lots of different ways to use it, and if you look through them, you'll see they're similar. Like they all can achieve a similar purpose, but they're all a bit different too. And so these are called method overloads. So just so we have that term defined for us here, right? These has 16 method overloads, and these are different ways, right? Different parameters that the method can take, right? 16 different combinations of parameters that the method can take. And 16 isn't a special number here, it's just that's how many overloads are defined by Unity. Right, so just to see, like this load scene has 6 overloads, 1 of 6. So you can either give it an int, or a string, or an int and a load scene mode, which I'm sure is an enum, or an int and load seed parameters, right? Or so different overloads there. So just so we have that defined, there's our there's the term method overloads. Okay. Going to just put this line up top there, and let's pick one. So what we would like to see is, I'm going to go down halfway through here or so. what we need to do is shoot a ray down from some known position, right? So that's going to be origin. We want to shoot it in a direction that's going to be down. Okay, we are actually going to end up using a layer mask eventually, but we won't use it yet. Let's see, which one should we pick here? This one seems pretty good. So here's an origin. So here's where we're going to shoot the ray from. Here's a direction, which is going to be down, and here's a distance of how far we want to shoot that ray. So we can put origin, right? Origin is just going to be the transformed position of this player. And so I mentioned before it's going to shoot down from the rigid body, but that's not necessarily true. It's just going to be from wherever the player's 0, 0, 0 is. So if I put, let's see, where is actual 0, 0, 0 here? I think this right here is, that's not going to change. I think this right here is where the ray is, but we can test that later. So put transform dot position. We can put this player back on the Z. That's fine. Okay, so we're going to shoot it from that origin. The next argument we need, we were on overload 7, is the direction. So that's going to be vector 3 dot down. Now here it doesn't matter how big this vector is, right? If it's -1 or -100, it's just a direction. Okay, vector 3 dot down. And the third one we're going to do is max distance. So the how far we want to shoot it down. And if we look at our player might have a height of about, it's hard to actually tell how tall this player is in world units, but let's say we shoot it down 3 units. And we'll see if we hit anything. Now, physics.raycast returns a bool. So this is going to shoot a ray downwards, but we only know what this gives us depending on the value of the bool that it returns. So let's say bool is hit equals, and then we'll say if is hit, right? So if we hit something, then let's add a force. Let's leave it like that for now, and we'll only be allowed to add a force if we hit something with this raycast. Let's try that. Okay, so we start on the ground. We should be able to add a force. Very good. Let me press again in the air, and I can't quite press when I get too high up in the air, but I can actually double press. So that seems like an issue. Maybe my ray is a bit too long here with the 3. Now, one thing we can actually do that's quite helpful is to do a debug ray. So if I write physics dot okay, so it's not physics, it's going to be debug dot draw ray. And here draw ray has some overloads as well. So we have a starting position, a direction, and this direction actually has a length to it. So unlike this one here, where vector 3 dot down is just a direction, here the direction actually has some distance. So we're going to start at transform dot position. Okay, our direction is going to be vector 3 dot down, and actually times that 3 that we put here, right? So that's how long it is. And I think they want a third argument, which might be color, unless we can just put a semicolon there. Yeah, that's one of the overloads. Okay, so we can debug.draw ray with just this position from this origin and going this direction and this distance. And we'll see what that ray looks like. In fact, let's change this 3 to a 2. And we'll go and try that. Okay, so playing the game here, we have, if I just pause it there for a second and I look in the scene, so you're not going to see it in the game, but if you look in the scene, I zoom into the player here, we should see a ray being drawn somewhere. Maybe if I let the game play, perhaps. Oh, you know what? This ray is only being drawn when we press get key down. So let's just take this, just stop it from running. Okay, let's take this draw ray and we'll just cut that out and we'll just put this in update so it's always being drawn. Okay, now we should be able to see this ray every frame. Okay, and if we try that, Okay, we zoom into the player. Right, and we'll just pause it there. So let's zoom into the player again with F, and we'll take a look at the player here. We should see a ray being drawn downwards. I think it's maybe this white line there. So you can see the actual transform origin, the origin of the player is actually right there, right where the ray starts, and 3 goes quite far down. So actually our origin being this close to the ground is quite nice. It means we don't have to draw a ray that's very far. It'd be quite accurate. So 2 is in fact quite long. Let's make this quite short. And let's go, instead of defining this number as 2 as well, let's define a length here. So just for testing, we'll go raycast length. We'll copy that raycast length, and we'll put the raycast length instead of 2. Okay, and then I want to set the player's speed to 0. So we'll be a little smarter about how we are testing this. Okay, set the player's speed to 0. We'll take a look at the ray. Okay, there's the player. So now the length of the ray, I think, let me turn off the music player as well, actually. Okay, so the length of the ray as well is going to be 0. If we increase that, we can see in the inspector, or not in the inspector, in the scene here, this length is increasing quite a bit or decreasing, so you can see it changing there. All we need is for that ray to be hitting the floor. Just make sure that the player's ray can be long enough to hit the floor. Probably 0.25 is probably plenty long. Okay, now this number is not going to save because we're currently playing. So let me stop playing and go to player, and we can set that raycast length as 0.25 again. Hopefully that's long enough. And we'll make sure the forward speed is, again, maybe 8 or whatever it was before. Okay, so we have a raycast that should be working. Okay, let's come back and just try that again. Okay, so if I press space, I can jump, but I can't really double jump unless I'm right on the ground again. So that looks really nice. Okay, let's just address one more element of raycasting here, which is layer masks, which could come in handy, not necessarily in this specific context, but definitely it will come in handy in different contexts if you're doing enough raycasting. So let's move the player back here, and let's put a different type of floor in. And what we want to make sure is that the player can only jump off of certain types of floors. So I'm going to duplicate this floor and move it towards the player, and just make it quite small, just a little section for testing. Maybe I'll make it bigger, it's fine. Okay, back here, it's okay. Let's make sure it lines up okay. Just okay enough, so that looks pretty good. And I'll make this a different color just for a quick demonstration. So I'll make this the orange color. Okay, so we're on the orange floor right now. And I want to make sure that I can only jump off of the floor and not this orange floor. And I guess one of the ways this could come up is maybe the player finds a way to jump off these obstacles, and I don't want them to. I only want them to be able to jump when they're on the floor. Well, let's make sure that we do that. So what we can do is use a layer mask. So what we're going to do is take this floor, and we'll choose a layer. We'll say add layer, and you can add some new layers in here, and I'll call this user layer 3. I'll call this jumpable, maybe. So user layer 3 is called jumpable. And then if I head back to the floor, now I can choose this layer is going to be jumpable, and this layer is just going to be default. And so I can only jump off of a jumpable layer. So let's define a layer mask where we can set what layers we can actually jump off of. So if I go to the player, this jump script currently has a force and a length. Let's add one more field there. Okay, that's going to be a private layer mask, and I'll just call this a jump layer mask. Okay, and layer mask is a struct, so it's going to appear right in the inspector. It's a value type. Yeah, that's another big topic is these value types like float and layer mask. versus reference types like rigid bodies, but that's for another time. But the point is, layer masks are going to appear right in the inspector. So instead of nothing, right, I can choose what layers I want to be able to interact with here for my jump script. I'm going to choose jumpable, and you can actually choose multiple. So this is similar to an enum. It's actually a bit mask. So another topic that's pretty interesting if you're interested in computer science and math. But we'll just choose jumpable, and you can choose multiple if you want, right? But I'll just choose jumpable for now, so just the one. And so we need to actually make sure that this layer mask gets applied. And we do that just in the raycast by saying, this is just jump layer mask dot value. Okay, and that's going to take the value of whatever this layer mask is giving you. So in this case, it's giving us the jumpable layer. Right, and we should be able to only jump if the raycast hits a jumpable surface. So let's just try this out right now. I still can't jump right now, and as soon as I hit a jumpable surface, I can jump, thus ensuring I can't jump off anything else. And now if you had another thing you wanted to jump off, so say for example these obstacles you do want to be able to jump off of, well, I can go into obstacle, I can put that on the jumpable layer, or put that on a new layer, say call it obstacles, the obstacles layer, and now the obstacles are on the obstacles layer. So every type of game object, or every game object, is only on one layer. But then my layer mask for the player could say jumpable and obstacles. So I can do those. Both of those are ones that the raycaster are going to hit. Okay, but for now I'll just use jumpable. I will actually remove this layer from obstacles there. Okay, so save that, go back. We should have default for these obstacles again. I guess I need to set default. Okay, for these obstacles. And that should be working. So let's just clean that up a little bit in the code with our raycast. This bool is hit is actually being checked directly by this if. So I can take the raycast and put that directly inside the if. So I'm going to say if physics.raycast, this check here, then add a force. So this returns true if I hit something that aligns with the layer mask, and false otherwise. Okay, I don't need this ray anymore either, so let's clean this up. There's my jump script. It's just these three variables at the top, plus rigid body, plus awake and update. Okay, that's it for this lesson. Your challenge in this video is to use a raycast to check whether the player is on the ground, to only allow the player to jump if they are on the ground, and as a bonus challenge, see if you can implement a double jump. So I will let you pause the video and try the challenge. There's nothing for us to show after. I'll let you decide for yourself if your double jump is working, but I won't add it in this video just for the sake of time. But that's it. So go try the challenge, make your jump work, and we'll see you in the next video.